No. Okay, this one is elimination. Remember this guy? It's called hydrogen. Hydrogen. So it's the same thing as almost the other one we had. So now that means we are going to remove it. We put dehydrogenation. Removal of hydrogen. So the next one, it's actually, if we were adding, we'll call it a hydro. I'm just capitalizing so that you can see the two words. Hydrohalogenation. That is if it was addition. But now, because we are removing, we put the word DE there. It becomes dehydrogenation. So this one was for water. Water, we call that one hydration. It's hydration. So since we're going to remove it, we have to start with the letter DE. Is it making sense?
Yes, sir.
So these times we are going to make double bonds or make triple bonds. We are making them. We are not destroying them. All right. So here's what's happening. Let's start with the first one, the one that I'm putting in the yellow box. And I put it in the yellow box. So that guy. Okay, let's just see. The process is often referred to, you see, it's a loss of hydrogen. You see, dehydrogenation. If I removed D, it becomes hydrogenation, the additional. So, what happens between the two carbons? I need to form another bond here. I wrote that in blacks. That means I must destroy two carbons. One from the carbon on the left, the other one on the right. I remove this. Can you see? How many hydrogen did I remove there? 2, ne?
2, yes.
Yeah, so that means what I did is, this is what happened. I removed this guy. I removed H and H. And these two together, they actually give you H2. So that's why you have plus H2 now. Can you see that?
Yes, sir.
Okay. So let's go to the next one. The next one, you can see it's a removal of hydrogen and halogen. There it is. Hydro. That's hydrogen there. And then when you go further, halogenation. That's that. So because they put D, we are removing hydrogen and one of the what you call. So that means if I form a double bond, one hydrogen must go. But the other side, I can't remove hydrogen. I must look for chlorine, bromine, which is that X there. So that means what I've removed now, I removed H and X. These two becomes XH. If H was chlorine, do you see now?
Yes.
Yeah, so this thing, they need a base of potassium hydroxide to actually break, to create those bonds. All right, I've got 2 minutes left. That means I'm going to stop by elimination because the other one is just esterification, is very chop. All right, loss of water. Come on, H2O. Water we know is hydration. It's hydration. To remove water, I must put DE. There is the name there, dehydration. So remember I said water. Water, it's actually H. with an OH. It's from the alcohol. That means water can be removed from alcohol. That's why people who drink alcohol, they go to the toilet to remove water all the time. You've seen that, right? Just think of them. People who drink alcohol must go to the bathroom to urinate, to remove water. It's exactly that. That's why. It's exactly this reaction. So you remove the H, the other one can't be H, it must be OH. So now you can see, you said, okay, I've removed the H and the OH. And this together can be written as, I've got H2O. You see, and then once you do that, remember you must have a bond there in the middle. There we go, it needs heat and acid. Is it making sense, my friend? I don't have any other reaction. Everything is done, and we are exactly 8 o'clock.